Kimberly has collected data on the number of students in the sophomore class who play a sport or play a musical instrument. The percentage of students who play a musical instrument and play no musical instrument, and at the same time, those who play a sport and do not play a sport, those who play sports or no sports are shown in the diagram below. Start with part A. What is the probability that a randomly chosen student will play a musical instrument and play a sport? Remember, with and statements, we multiply. So we're first going to find where is the one that says plays a musical instrument. Up here, that is plays a musical instrument is 10%. We write it as a decimal. Remember, with and probability, we multiply. Now from there, what is the chance that they also play a sport? Plays a sport is 38%, 0.38. We're going to multiply them, and then we'll answer the question in the format that they'd like us to. So here's the answer. It says express the probability as a percentage rounded to the nearest tenth. So I move the decimal two places to the right, and this is 3.8%. Going on to part B. What is the probability that a randomly chosen student neither plays a musical instrument nor plays a sport? So this time we're going no music and no sport, okay? It is an and statement. So I come up here. No music is 90%, and then no sport is 7%. 90% as a decimal and 7% as a decimal. Let's multiply and then reread how they want the format of the answer. 0.90 times 0.07. And this time it says express the probability, again as a percent, rounded to the nearest tenth. This would be 6.3%. Going on to number 16 from yesterday. A card is randomly selected from a deck of cards. Now, what I've noticed in the past several years is I would say only about 15 to 20% of students really have worked with cards enough to know what a deck of cards looks like. So don't be embarrassed if you're like, yeah, I know what cards are, but I don't know exactly what is comprised in a deck of cards. So let me zoom in here so we can still see it on the video. All right, so a deck of cards. We have 4 different suits. Each suit consists of 13 cards. If these are things you don't know, you should write them down. If you feel comfortable, then don't worry about it. But this picture will not be there for your AZ Merit, and it will not be there when we do problems today. So there's 13 clubs, 13 hearts, 13 spades, and 13 diamonds. We can see that half the cards are red and half the cards are black. We call these face cards. There's 3, 3, 3, and 3, so there's 12. There's 12 face cards. And a card is defined as a face card if it has the face of a jack, a queen, or king on it. So somebody said, how many 2s are in the deck? There are 4 2s out of 52 total. How many face cards in the deck? There's 12 out of 52. Okay? We're going to go back to this problem, and let me zoom out here. A card is randomly selected from a deck of 52 cards. What is the probability that it is a red card or it is a face card? Please circle the word or. Remember, you have to memorize the or statements. You can look on the board for now, but that will be erased after today. So an or statement, we have to decide, are they overlapping? Okay, because if they're overlapping or they're disjointed, that determines which formula we use. So are there red cards that are also face cards? Are there red cards that are also face cards, yes or no?
Yes.
That means they are overlapping. So when they're overlapping, this is the formula we must use. Probability in this case of red or face card is equal to the probability of red plus probability of face card. Subtract the probability of their intersection. How many red cards in a deck? There's 13 diamonds and 13 reds. So 26 out of a deck of 52. How many face cards? Again, there is 3 spades, 3 clubs, 3 hearts, and 3 diamonds, a total of 12. And how many red cards are also face cards? Well, there is a jack, queen, and king of hearts, and a jack, queen, and king of diamonds. So 6 total. Grab your calculator It does not state how it wants the answer, so we will leave it as, we know it's probability, we'll leave it as either a terminating decimal or as a fraction in lowest terms. 26 divided by 52 plus 12 divided by 52 minus 6 divided by 52. It's not a terminating decimal. Turn it back into fraction, and we end up with 8 over 13. Going on to number 17 next. Please cross out at the right, it should be below. Okay, number 17, please read it to yourself. It says of 40 students in all, of 40 students in an on-campus club, 14 are taking AP English, 29 are taking chemistry, and only 2 of the 40 are not taking English or chemistry. So let's put a, bless you, tape a 2 down here. This is AP English. This is Chem Honors. So of the 40, only 2 are stated they're not taking either. So what is left to find out? We need to know English, we need to know chemistry, and we also need to know where the overlapping occurs. When I look up here, they tell us English and chemistry, but they don't tell us overlapping. We know there's going to be an overlap because it's provided in the graph. So here we go. It's an overlap occurs with or statements. So we have the probability of English or chemistry is equal to probability of English plus probability of chemistry minus their intersection. Of the 40 students, we know 2 are not taking chemistry or English. So if 2 are not taking, then how many total are taking English or chemistry? 38, because 2 are not taking either one of these. That means 38 must be taking them. So I didn't leave enough room. Down here I'm going to write 38 over 40. That represents this portion. Put an equal sign. How many are taking English? 14. 14 out of 40. How many are taking honors chemistry? 29 over 40, and we don't know the overlapping. That's what we're trying to find. But notice it's a subtraction sign. So subtract, I don't know this quantity, so I'm going to write subtract x. When I do get an answer, I want something over 40, okay? So maybe it's like 10 over 40 or 8 over 40. All right, so here we go. Let's first add up these two. 14 divided by 40 plus 29 divided by 40. And because it's a terminating decimal, I'm okay with you not turning it back into a fraction if you don't want to. So let's isolate this. We want to find out what x is. So I added these two together and I came up with 1.075. Now to move it to the opposite side, you're going to subtract. So I'm going to take this thing, this quantity, subtract this number. 38 divided by 40, subtract the quantity 1.075. And I'm going to turn this back into a fraction. So negative 1/8 is equal to negative x. Now in your math career, you've learned if you have some negative quantity equals a negative variable, if you divided or multiplied both these sides by negative, what would happen? You'd end up with positive on both sides, right? So this is what x equals to, and that's not wrong. But I want to change how this fraction is written. So this fraction, I need to keep the same value, but I want to write it so you have 40 on the bottom. That represents the 40 students. So what do I have to multiply by? 5 on top and bottom. That means that 5 over 40 is the same thing as 1/8. Remember, x was representing where they intersect, where they overlap. So how many students are in both English and chemistry? 5. Now English had a total of 14. Well, there's already 5 here. So what number plus 5 gives you the 14? And chemistry honors has 29. 5 plus what quantity gives you 29? That's the hardest part of the problem. Okay, we're going to do true or false. 2 students in the club are taking both AP English and honors chemistry. Is that true or false? False, because it's actually 5. 24 students are taking honors chemistry but are not taking AP English. Is that true? 24 are taking honors chem but not taking the AP. True. The probability that a student is in AP chemistry or AP English or honors chemistry is this. Well, remember, the probability of English, AP English or honors chemistry is this fraction. So do me a favor, divide and tell me what you get for a decimal. Is it 0.95? True statement. The probability that a student is taking both classes is this. So we know there's 5. Take 5 divided by 40. Is it 0.125? True statement. The probability that as a student is in AP English but not in honors chemistry. Again, the probability that a student is in AP English but not honors chemistry. So how many students are in AP English but not honors chemistry? 9 out of 40. Please divide. Is it the same as 0.35? A randomly chosen student is more likely to be in both classes than in neither. Okay, a randomly chosen student is more likely to be in both classes than in neither. So are there more students in both classes than not taking any? So how many students are in both classes? 5. How many students are in neither?
2.
So do you have a better chance of randomly choosing a 5 than a 2? Yeah. The probability that a student is in AP English, here's the given, circle given they are in honors chemistry. So we are only going to look at honors chemistry. So honors chemistry has 29 students. We're only focused on this. Now, of those 29, how many of them are also taking AP English? So please take 5 and divide it by 29 for me. And is the answer 0.225? False. Please take out the new packet. My goal for you, flip to the very back. My goal is in the next 10 minutes to help you better understand how do you know which type of and statement we're going to use or statement with probability. So do me a favor, remember there's a few more words here than we needed. Give me 1 second. I made corrections on one of these. Please read number 16, one person in your group. The odd cheer receives a promotion at work this year are 1 in 4 chances. The odds she will be audited by the IRS are about 1 in 118. What are the odds that she will get a promotion, circle the word and she will get audited by the IRS? So when we're talking about and statements, we know we always multiply, okay? Ands means multiply. So let's go probability of promotion and I'm going to say audit. Now what you have to decide is, are they dependent? Like if you're like, what does she mean dependent? Do you remember yesterday we did the problem with, we had all the tiles that spell out Mississippi? And we said, what's the probability of selecting one tile, it's an S, you put that S in your pocket, and then going back and getting an I. And the second event is impacted because you put one of the tiles in your pocket, you didn't put it back in, right? Do these two have anything in common? Are they at all affected by one another? No effect. Okay, so we're just going to multiply. So the probability of getting a promotion times the probability of getting audited. Promotion is 1/4. Audit is 1 over 118. Please multiply. And because it does not give us specifics, leave your answer either as a decimal if it's terminating or as a fraction in lowest terms. It is not terminating. So I'm going to hit math fraction, enter, enter, and 1 over 472. Can you help me out? Thumbs up, to the side, or down on your understanding of that particular problem. Okay, here we go. Go on to number 17. I got to look here. Please change this word to or. Jack or a heart. Have one person please read it. What is the probability that a card chosen from a standard deck will be a jack or a heart? Okay, here we go. Probability of jack or heart. So with or statements, we have two formulas. One of the formulas looks like this. The other one looks just the same, but then you have to subtract the intersection. So how do you decide whether you stop here or you subtract the intersection? That's all determined if there's any overlapping. So here's the overlapping. Are there jacks that are also hearts? Are there jacks that are also hearts? Okay. If there's an overlap, then we have to go minus P of jack intersect heart. So how many jacks in a standard deck of 52? There's a jack of hearts, diamonds, clubs, and spades, so there's 4 out of 52. And how many hearts are there? 13 out of 52. Then how many jacks are also hearts? 1. Okay, use your calculator. It does not specify how they want the answer. So again, it's a terminating decimal or a fraction in lowest terms. This is not a terminating decimal. So I'm going to hit math fraction, enter, enter, and I have an answer of 4 over 13. Who has an answer of 4 over 13 just so I can see? Great job. Does anybody want clarification on that problem? Okay, go ahead. Have one person please read 18. A committee is composed of 52 candidates. 4 persons aged 18 to 21. If one person is randomly selected, and then without replacing the first candidate's name, a second person is randomly selected, what is the probability that both candidates will be between the age of 18 to 21? Okay, so I'm going to refer to this age range as like college, okay? Because you agree that most kids 18 to 21 are in college or entering? It'll just help us for this. So this is saying, hey, what's the probability that we choose a college-aged kid the first time, and we go back and we choose a college-aged kid the second time? Now here's the kicker. It says that picture we have like some type of device, maybe even something like a hat, and everybody's first and last name goes on a piece of paper and goes into the hat. We have 52 candidates' names that are going to be in the hat. What's the chance that the first one gets chosen happens to be a college-aged kid? 4 out of 52. Remember, and statements we always multiply. Now because we don't replace that name, we choose a name out, okay? We choose a name out. Name happens to be Maria Carter, okay? We put Maria Carter's name off to the side. She's a college-age kid. She's one of those 4. And now we go back into the hat to grab another name. We're looking for a college-age kid. What's the probability of that? How many college-age kids exist in the hat right now? 3, but how many total people exist? 51. Right, dependent. It's dependent because the actions of the first event, because you didn't replace the name, impact the actions of the second event or the outcome of the second event. Okay, it does not say how they want the answer, so again, we'll do the same thing. Terminating decimal answer or written as a fraction in lowest terms. One over 221 is the answer I came up with. Does anybody else get that answer? Okay, would anybody else like me to go over this problem again? Okay, go on to number 19, please. One person reads, and I do need to change something. Please cross this out for me on your paper. Okay, one person go ahead and read. It's an and statement. So let's write this down. We want to know the probability of Martha and Jerry. So remember, and statements you always multiply. Here's what we have to know. Does Martha hitting rush hour traffic have any impact on Jerry hitting a hole in one in golf? No impact. So, and here's the next thing that makes this a little bit confusing. When you put your answer down, if they give you a percentage, you have to write it as a decimal. 65% written as a decimal is 0.65, and the most confusing part of this problem is 0.08% written as a decimal is 0.0008. Please multiply. And most students get to this point and they're like, okay, what does this mean? So this is in scientific notation. Please write down 5.2. This negative sign means I'm going to take the decimal and I'm going to take it 4 places and move it 4 places to the left. 1, 2, 3, 4. And then change it and put the decimal there. If it would have been a positive 4, you move to the right. Any place that's blank gets a 0. A common mistake I see students make is they're like, what do I do with that negative sign? And they throw a negative sign in front of the final answer. Your final answer is 0.00052. You are going to do number 20 with your partner. One person reads, you do the problem, you write your answer as a fraction in lowest terms, and let's see if you can be done in 45 seconds. What is the probability of choosing one card from a deck and either getting a queen of hearts or an ace of hearts? So you're only going to draw one card. So you don't even need to worry about replacement because it's only one event. It's also an or statement. Remember, or statements are the first 2 on the board. So now you have to decide, is there an overlap? Can a queen of hearts also be an ace of hearts? No overlap? So since there's no overlap, we're just going to take probability of choosing a queen of hearts plus the probability of choosing an ace of hearts. How many queens of hearts exist in a standard deck of 52? How many aces of hearts exist? If you add these together and you put it in lowest terms, I believe I came up with 1/26. Okay, flip over please to the front. Look at number 4, please. What do we do with and statements? How do we handle them? We multiply. We multiply, and notice it says they're independent. We multiply, so I know that P of A and B is equal to P of A times P of B. So this and statement has an answer of 0.06. We don't know P of A, so I'm going to put an X. And we know P of B is 0.3. To isolate the X, I'm going to divide both sides by 0.3. And I can see that X is equal to 0.2, which is P of A equals 0.2. One person needs to only read the top part and part A, but please don't go through the actions of solving. One person, go ahead. this works, we have a coach's bag, and inside there happens to be how many ribbons total? Not 8,
20.
not 12, but 20, because you add them together. So we have this bag here, again, I'm no artist, I know. There's the bag, okay? And we have ribbons inside. Okay, and there's 20 ribbons total. And how this works is Kathy's just going to put her hand in, she's going to grab a ribbon out. By the way, what color is Kathy choosing by chance? It says Kathy is hoping to get a what?
Red.
Let's see here. Probability of Kathy chooses and then Maria. Oh, my fault. Maria chooses first. She's going to get a blue. And then after that, Kathy chooses and Kathy is going to choose a red. So my fault. So Maria goes first. She puts her hand in. She chooses one out. It's a blue. Great. Is Maria throwing it back into the bag? No. So there's no replacement. Please write no replacement. That means they are dependent. So when I do blue first, remember with and statements we multiply. How many blues exist in this bag of ribbons?
12.
So we have 12 total and 20 ribbons. Now next up is Kathy. Kathy goes in hoping for a red. How many reds exist? 8, but recall that Maria kept one of the ribbons, so there's only 19. Please get an answer and write your answer as a fraction in lowest terms. Who's comfortable with 24 over 95? 24 over 95? Okay, so explain why the events are dependent or independent. Well, we know they're dependent, and for time's sake, I'm not going to have you write down your answer right now, okay? Just for time's sake. But what could we have said? So turn to your partner, Louise turning around to the group in back of you, Jacob turning around to the group in back of you, Miguel talking to the group in front of you. And I want in 30 seconds for you to come up as a group is what could be an answer that you feel confident in getting right. Go. So something as simple as this does not have to be the same, but something as simple with the same meaning. The probability of randomly selecting a blue ribbon from the bag does affect the probability of randomly selecting a red ribbon from the bag since the first ribbon was not replaced. Thus, the two events are dependent. Please flip over and find number 6. I'm going to give you a 30-second head start. You are going to do number 6 with your partner. And let's see if you can have it done in a minute 15. I'll give you 30 seconds head start. Go. And statements, what do? We multiply. Because we're replacing it, we can do the probability of, is it football first? Football and basketball. So probability of football is 8 out of 10 times the probability of basketball is 2 out of 10 because it was replaced. Then it asks us to get an answer and round our final answer to the nearest hundredth, which is 0.16. Thumbs up or thumbs down right now?